Okay, dear, because if you are recording, once you have recorded it, it gets you very complacent feel that it is there with you. Will not be that easy for you to figure it out. You'll have to go through entire segment of 2 hours, thereby losing on time. So you record, that is good for repository, but you do not in any way departure from the habit of writing. Clear, dear?
Yes, sir.
In the notebook which you are keeping beside of you, please do write the escapes, right? And what are they for you? Moment of inertia was actually, we had this term, if you can recollect. We had this term, and this was from I is equal to 1 to I is equal to n. We got this term in our derivation for angular momentum of a body about fixed point, correct?
Yes, sir.
A body was rotating about fixed line or fixed axis, which we call a case of rigid body rotation. Can you recollect?
Yes, sir.
We call a case of rigid body rotation, and then if we went and find that L for that body, which is angular momentum about the axis of rotation, is summation of mi squared
Into omega.
equal to n into omega, and when we write it to the left of equality, we are reading for magnitude. And what exactly it is Lz, which is what to us? It is z component of angular momentum. This, not to say, by the way, let me clarify out here, it is not in any way to say that Lx and Ly are 0 over here. Please don't overread me. Please don't overread the derivations. I didn't comment on Lx. I didn't comment on Ly. Thereby, I refrained from saying anything on Lx and Ly. I just did say that Lz is equal to I into omega, which is what to us is Iz into omega z. You can write it this way as well. Because Iz means moment of inertia about axis of rotation, which for us being z axis. I have taken that axis to be z axis, correct? Yeah?
Yes, sir.
So I can write Iz. If you have taken that axis to be x axis, you can write over here instead Ix, correct? Because this I is basically what to us? Moment of inertia about axis of rotation. Clear, dear?
Yes, sir.
I is moment of inertia about axis of rotation. This Lz is what to us is angular momentum about axis of rotation. And when we found it, you can recollect, we dropped the idea of vector. Thereby, we don't qualify commenting on Lx and Ly. We cannot say that they are 0. Yes, we can say they are 0 for one case, and that case was read out to you. Isn't it? What was the case, dear? We can say Lx will be 0 and will also be 0 Ly for one case, correct? For one case, correct? Yes or no, dear? Yes or no? Come on.
Yes, sir.
Fresh.
Yes, sir.
Show me all of you. Show me on screen, all of you. Please show yourself. Show yourself. I want to see all of you. Show yourself, all of you. Vedant, show yourself. Vedant, show yourself. Vedant, are you there? Vedant. Are you there, Vedant? Vedant, can you hear me?
I don't.
Yes, show yourself, Vedant.
Yes, sir.
Show yourself.
Yes, sir.
Yeah. Now look over here. Please be very careful. I want to read your facial expression over here. That's the reason I asked you to show yourself. LZ is what I repeat. LZ is only to tell you angular momentum of the given body about axis of rotation. Clear, dear? Clear, dear? Clear, all of you?
Yes.
LZ is what to us, all of you, please? LZ is what to me? LZ is to me angular momentum about axis of rotation. I am writing LZ owing to the fact that my axis of rotation, as you can refer your notebooks, all of you, our axis of rotation, what was the axis of rotation taken by me? Axis of rotation taken by me was Z axis, correct? Yeah.
Yes, sir.
Please endorse, all of you. Please endorse. The axis of rotation that I did take, this axis was Z, correct?
Yes,
Correct.
Yeah.
Okay.
Yes.
If I take instead axis of rotation as Y, what does this mean? That it is rotating the body, three-dimensional body is rotating about which fixed axis? What does it mean? Three-dimensional body is rotating about which fixed axis or which is axis of rotation? Tell me, dear. What will you say?
By
What is axis of rotation? Y-axis, agreed?
Yes, sir.
Yes.
Agreed, all of you.
Yes, sir.
Yes, sir.
How will this change? Tell me. How will this change? What do you write now? Yes, please. You're saying something. Tell me, dear.
yeah, so it'll be Ly is equal to Iy into omega y.
And Ly is equal to Iy into omega y. Are you getting it, all of you?
Yes, sir.
Did I say a word on LZ and Alexia? Did I say a word on LZ and Alexia? Think about it. Did I say anything on what will be LZ or what will be LX? No, I didn't.
Yes, sir.
And what makes me be cautious on it? Tell me, dear, why I'm cagey about saying anything on LZ and LX? Tell me, please. Why I'm paranoid? Why I am exercising caution over here? Any one of you, Adesh, it goes to you. Why I'm exercising caution? Why I am deliberately stopping short of commenting on LZ and LX. Tell me, please. Why am I? Why am I?
So is it because we don't have any tool to calculate the
Exactly.
number of?
Because we don't have any inkling on what will be LZ and what LX, correct?
Yes, sir.
Yeah.
Yeah, we don't have any inkling on what will be LZ and what LX. Can you tell me when can I be sure of it? Can you tell me when can I be sure on LZ and LX? When can I be sure on LZ and LX? Yes, Adesh, could you please help me on that? When can I be sure on? Can there be ever a situation when I'll be sure on LZ and LX? Krish, can you throw some light? When there be a situation, Krish, when I'll be sure on LZ and LX? Can you throw some light, Krish?
So, 1 second, sir. Let me think. I'm not sure. Like
Come on.
it should be 0. So,
No issue. Think about it.
sir,
When
it
can
should
I
be.
be sure on? When can I comment? When can I comment? Or if you say that no, you can never comment on it, so be it. I'll accept that even.
So is it only like so there are no position
Can we say-
vectors. So basically, it should be only along y-axis.
If it is along y-axis, then it makes no point because L itself will be 0.
Oh yeah.
L itself will be 0, right, dear? You said the same the other day, but then L itself will be 0 because moment of inertia will be 0, R will be 0. What is R in moment of inertia? You can read from your equation.
Yeah, yes, sir.
R is the perpendicular distance of any point from axis of rotation, correct?
Yes, sir.
I think that we took Ri. Please do correct me. Did I take Ri prime or Ri?
Ri, sir. Ri.
Ri prime or Ri? What did I take the other
Ri
day?
prime was for sir. Ri prime was for S prime frame.
No, that was yesterday. The day then when we were dealing with this, what did I take for
So
the
you took
perpendicular?
Ri prime for LG axis.
I took Ri prime. Prime is not always to moment of inertia. I said that generally prime is subject to moment of inertia. If you go back to this derivation, I took Ri prime as the perpendicular distance of Mi, correct?
Yes, sir.
Please
Yes,
do
sir.
check.
Yeah,
So I'm
yeah.
writing over here in consonance. In consonance with what I took the other day, I'm writing over here. I'm changing this to Ri prime. Is it okay?
Yes, sir.
Yes, sir.
Okay. Please don't read it
Yes,
as
sir.
moment. Please don't read it as. Please don't read it as it being the perpendicular distance from center of mass frame. Clear?
Yes,
Yes,
sir.
sir.
Center
Yes,
of
sir.
mass I introduced only yesterday. Clear?
Yes, sir.
Yes, sir.
Of
Yes,
mass I
sir.
introduced only yesterday. Clear? And then
Yes,
I
sir.
Yes,
told
sir.
that whenever we deal with center of mass frame, it is a customary to represent it with a prime. Clear?
Yes, sir.
That
Yes,
in
sir.
doesn't make you take blanket perception on prime. Clear?
Yes, sir.
Yes, sir.
As you can see for yourself, this being a departure, we have used prime in our day before yesterday class, and there what we took prime was not as read from center of mass frame. Clear?
Yes,
Yes,
sir.
sir.
What was prime there? Was perpendicular distance of ith particle as read from S frame, right, Krish?
Yeah, yes, sir.
Right, Vedant. What was it, Vedant? Perpendicular distance of ith particle as read from which frame? As read from S frame. Clear?
Yes, frame.
Yes, sir.
Yes,
Yes, sir.
sir.
What was S frame or what is S frame in general? S frame is lap frame. Clear?
Yes, sir.
S frame is lap frame to us. It is not center of mass frame. Clear?
Yes, sir.
Yes, sir.
Okay, so please make that distinction. This now is certainly to you, this factor, Ri prime as per what we are coming from. I repeat, Ri prime as per what we are coming from is perpendicular distance of ith particle from axis of rotation. Can we say that?
Yes, sir.
Okay, so remember it that way. This is Ri prime to us.
Yes,
This
sir.
is what we took the other day. Clear? Clear to all
Yes,
of
sir.
you?
Yes, sir.
Okay,
Yes,
good enough. Now tell me, think about it, and you all do. Deem, answer me something against it. Even if you don't go to the nuances, you will get something to speak about. Very simply, my summation being very simple. Can you tell me when can I be sure of LZ being 0 and LX being 0? Can I ever meet a situation in which I can be sure LZ and LX both being individually 0? Think about it. Think about it. Both being individually 0. Because when both are individually 0, let me tell you what will I get. As I wrote the other day, I write for you again. If both are 0, then we get this equation. If both are 0, then we get this equation. It will lead to this equation, which is L vector is equal to I into omega vector. You can never write L vector is equal to I into omega vector otherwise. Wherever you will find, even in good books, you will find L vector is equal to I into omega vector are mentioned. Please cross it straight away, unflinchingly, unabashedly cross it. It is incorrect, abominably incorrect. To write L vector is equal to I into omega vector. It is not correct. Why is not correct? Because when we read, we have dropped on purpose the idea of finding anything on Lx and Ly. So we go for only one component, and that is the component corresponding to axis of rotation, right? Yeah.
Yes,
Yes,
sir.
sir.
That
yes,
is
sir.
the component corresponding to axis of rotation. If axis of rotation is if axis of rotation is X, we are reading for Lx. If Y, Ly. If Z, Lz. And accordingly, we adjust omega and I. Accordingly, we adjust omega and I. But as we have no inkling on what can be the other components,
Sir,
we cannot say that L0, Lx0, so Ly is L vector. When can we say, let me ask you, rephrasing my question, when can we say that 5 is a vector. When can we say, let me ask you a question. Very simple question. Given to you that AX is equal to 5. Given to you AX equal to 5. Can you say anything on A vector?
No.
Given to you AX equal to 5. I'm asking a very simple question from vector.
Yes, sir.
I have
You
picked
can
a very simple question from vector. Given to you AX is equal to 5. And then the author says, write A vector. Can you write for A vector?
So you
Can
cannot.
you write?
So you
Tell me.
don't. So the Y and Z component will be ambiguous. So you won't know what is there.
Exactly. So what we can say? We can say at best it will be 5I cap plus AYJ cap plus AZK cap, right? Yeah.
Yes, sir.
We can
Yes,
say
sir.
at best this only, that it will be this to us. But this doesn't get me the vector as we don't know a thing on AY and AZ, right? Yeah.
Yes, sir.
Right.
Yes, sir.
Now I qualify my ask with AY being 0 and so being AZ. Clear?
Yes, sir.
I reveal, I divulge that AY is 0 and also is AZ 0. Is it okay?
Yes, sir.
Yes, sir.
Then ask you the same question. Then ask you the same question, which is tell me what is a vector. What will you say now?
5 I can.
Correct.
Yes.
5.
Now you will say a vector will be 5I cap. Clear?
Yes, sir.
Yes,
I
sir.
wanted to bring forth this point. I wanted to bring forth this point. If I say LZ, I am known to only LZ, right?
Yes, sir.
LZ. I'm known to only LZ, right? I am
Yes,
not
sir.
known to LX and LY, correct?
So
Yes,
one
sir.
small thing. So will
Right,
LX and
Krish?
LY. Yes, sir.
I
So
am
will
not,
LX.
if I'm saying LZ, then I'm not known to LX and LY, right, Krish?
Yes, sir. Yes, sir. So I'm
Yes,
asking.
sir.
I cannot. I don't qualify. I am not eligible to comment on L vector. Yeah. I am
Yes,
not
sir.
eligible to comment on L vector. Yes or no?
Yes,
Yes,
sir.
Yes,
sir.
sir.
When do you feel that I'll be eligible to comment on L vector? When can I be eligible to comment on L vector? If I know on Lx and Ly, correct, dear?
Yes, sir.
Yes, sir.
Yes,
And as of now, I'm not known to. But let me tell you, they are 0. They are both 0. That means Ly is 0 and also is 0 Lx. Clear?
Okay, sir.
yes, sir.
Y is 0 and also is 0 Lx. Clear?
Yes, sir.
Yes, sir.
And
Yes,
then
sir.
ask you again, can you comment on L? You will at once say yes. Say me yes or no.
Yes, sir.
Will at once say yes. Now we can comment on L. Then I'll ask you what is L. You will say L will be LZ into K cap, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
Correct or not, class? Tell me here.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes. So this you can, provided you know everything about Lx and Ly. And you can never know anything about Lx and Ly. You know why? I am taking you back to what did I tell you? It is very difficult to find what is Lx and Ly to sum to for system taken. Why so? Because Lx and Ly are rotating vectors. Clear?
Yes,
What
sir.
are
Right.
Yes,
Lx for any system? Lx and Ly are
Rotating
rotating
vector.
vectors. They lie in which plane? They lie in xy plane. Clear?
Yes, sir.
So as the body is rotating, their final value, if you take the pain of finding it out, which again is onerous task, a harrowing task, but if you at all take the pain, even then you will see that vector which you are getting will keep on rotating. Clear, dear?
Yes, sir.
Yes, sir.
Rotating in which plane? Rotating in XY plane, right, dear?
Yes,
Yeah.
sir.
Yes, sir.
So we cannot find anything. We can't say anything on LX and LY, but for one case, anyone.
So is it when velocity along x direction and y direction is zero?
Yes, Krish. Yes, Krish. Tell me, dear.
Sir, is it when velocity along x direction is zero or something like that?
The
Constant.
body is rotating, dear. The body is rotating. So I cannot have say on velocity in a particular direction. Are you getting my point? As the body is rotating, velocity direction will keep on changing, Krish. Correct, dear?
Yes, no, sir. I'm telling along x direction and y direction is zero.
Velocity direction. See, the body is rotating, right, Krish? So
Yes, sir.
direction of velocity is not my prerogative.
Okay. Yes,
It's
sir.
not under my discretion. Are you getting it?
Yes,
Are you
sir.
getting it, Krish?
Yes,
So
sir. Yes, sir.
can we say when the
What we can say, we cannot comment on it. Velocity will keep on changing. Look over here. This finger is the velocity direction. Show yourself, Krish. Show
Yes, sir.
yourself, Krish.
Sir, I'm here only, sir. My book
Here
was
is-
covering.
look, this is the circle that I'm moving. The particle is moving in, right, Krish? So this finger is direction of velocity, right?
Yeah.
Now what will
Yes, sir.
happen to this finger? This finger is changing its direction. See for yourself. Yes or no?
Yeah. Yes, sir.
So velocity will keep on changing its direction. It is continuously changing its direction. Yes, I can say it will have no effect on z direction, but I can no way say that this will be not changing its direction in plane xy. Are you getting it there?
Yes, sir.
So there I have no choice. I don't have a choice to make on it. Yes, dear. Adesh, you are saying something.
so if we consider the body to be like just along the x-axis and the z-axis, so just that
Okay.
it doesn't have any point that lies in the x or y frame.
Okay.
So
Okay.
like the body is just made of single points.
Okay.
So
And
then
where are they? Where are the points? Suppose body is made up of 2 points. Fine. Where are those points?
so at the origin and along the z-axis.
No, then again, if you that is what Krish did here. That is what Krish did here. But if you take it along the axis or on the axis rather, you are taking it on the axis of rotation. Clear, dear?
Right, yes.
So if I take it on the axis of rotation, think about it. If I take it on the axis of rotation, then what are you getting? Then you are getting perpendicular distance of particles that the body is made up of as zero.
Right, yes, sir.
Are you getting it or not? Then I
Yes, sir.
get the perpendicular distance as zero.
Right, yes, sir.
If I get perpendicular distance as zero, there is no point studying for angular momentum.
Okay, yeah, yes, sir.
Angular
Yes, sir.
momentum. Angular momentum is product of something which depends on perpendicular distance with omega, right? Yeah.
Yes, sir.
Yeah.
And
Okay.
you're suggesting that the two particles that your system is made up of, for both the particles R1 prime and R2 prime respectively are zero. Correct, correct, Adesh?
Yes, sir.
So it dilutes my effort, isn't it? It defeats the very purpose. Clear, dear?
Right, yes, sir. We can't consider that.
Okay. So it cannot be on axis. It cannot be on axis. And mind you, I told you that we are dealing for a body which is three-dimensional.
Yes, sir. That's the only thing.
Go specific now. I cannot be cherry picking now. I'll have to read this for a three-dimensional body.
Right,
Come on,
yes, sir.
I want any one of you to speak. This is the spunk which I require in my students. I want this distinction to be there with my student vis-a-vis other students. And that is what we are known for, the peers which we keep. And I keep it very selectively, you know that very well. You all have passed an examination to be over here, correct? And
Yes,
that
sir.
examination was not namesake. I do reject student. That also is known to every one of you, correct? Yeah.
Yes, sir.
Yes.
So please be very confident on your potential. Your potential, that's the reason you are there with us. Think about it, dear. Don't be an escapist. Think about it. You can answer. You can answer one case. You can get me one case. All of you are potential. You all can get me at least one case when a three-dimensional body will get you Lx0 and also Ly0 will get you Lx0 and also Ly0. Think about it. Think about it. Is any result out today? Is any result out today? I got an information.
So
So
what result?
I got an SMS just now of someone by the name of Hari. I don't know. 97% percentage. Is any result out today?
Sir, I don't know, sir. I don't think so.
Okay. Okay. Is it okay? Else, can you tell me, dear? Can you help me? My question is, can you help me translate equation? Can you help me take this equation, make this equation transcend the barrier of z and read it for vector?
Sir, is
Can
it
it
when
transcend the barrier of z? Can it transcend the barrier of axis of rotation and can be studied as a vector quantity? Anyone?
sir, is it like when ix and iy is 0? Is that the only case possible?
You can say when Ix and Iy are 0. You can say that. That I'll accept. When Ix and but then you'll have to reveal that which case can get you Ix 0, which case can get you Iy 0. Because anyway, I'm not, when I'm writing over here, Krish, for yourself, I am not taking Iy or Ix into account.
Yes, sir.
This is what to me? This is moment of inertia about which axis? About axis of rotation, right? Yeah.
Yes, sir.
So that in any way is Iz.
So the only case that's coming to my mind is when the body is massless.
When the body is massless, then again the same problem there. This time
Yes,
MI
sir.
will correct here. MI will be zero. Okay, let me throw a hint to you. Let me throw a hint to everyone. And let me take you back to the three-dimensional body that we began with. Let me take you back with the three-dimensional body that we began with. And what was that three-dimensional body? I took a particle over here. Correct me, Claudia. Correct me if I'm anyway digressing. I took
Yes,
a
sir.
particle over here, correct?
Yes, sir.
Yes, sir.
And then I told you that there are two components that you associate with this particle. One is towards the axis of rotation and the other is along the axis of rotation, right? Yeah.
Yes,
Yes, sir.
Towards the axis of rotation and the other is along the axis of rotation, right? Yeah.
Sir.
Right, sir.
Towards the axis of rotation, I told you, I don't have any qualm. Why don't have I any reservation? Is because for every particle that the body comprises of, every single particle that the body comprises of, you will get one component along the axis of rotation. Clear?
Yeah,
Yes,
yes, sir.
sir.
yes,
You will get one component always along k direction. Clear?
Yes, sir.
Yes, sir.
The other which is along the axis, sorry, perpendicular to the axis of rotation or towards the axis of rotation. The other which is perpendicular to the axis of rotation or towards the axis of rotation. What will happen to that component? Think about it. Is not that subject to particles position?
Yes.
Is not that subject to particles position? Say me yes or no.
Yes, sir.
yes,
Is not that always changing its direction? Yes or no?
Yes, sir.
Yes, sir.
So that factor will always change its direction. Clear, dear?
Yes,
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 sir.
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 So let me ask you, what was it for this particle? You will say, referring to your notebook, you will say that it was along minus j direction. Clear?
No, yeah,
Yes,
yes,
sir.
sir.
Was it? Was it? Refer, please. Do I
Yes,
don't
sir.
want this habit to get inculcated? I abhor this practice of referring when you are in class because I ensure that you don't require any reference. When I ask you to write after every class, I'm trying to ensure that you don't require any reference hitherto. Thereafter, clear, dear?
Yes, sir.
Yes, sir.
Please do inculcate habit of writing. Am I clear, dear? It will go
Yes.
a long way serving your purpose of seeing yourself through the gates of IIT. Please lay credence to what I'm carrying as rich experience, right, dear?
Yes, sir.
Please inculcate the habit of writing. It is very important for us. And this is not something which is my brainchild. This we know since time immemorial, an age-old practice, right, dear?
Yes,
Yes,
sir.
sir.
So for this particle, the particle which falls to the right of z-axis, you got the first factor in which direction, dear? Minus j cap, correct, dear?
Yes, sir.
Yes, sir.
Now this is the bone of contention to me. This is the Achilles heel in my calculation, right, dear?
Yes, sir.
Yes, sir.
Yes, sir.
This is not the Achilles heel in my calculation because this is something which I cannot calculate for body, correct?
Yes, sir.
Yes. Yeah,
So
yes, sir.
if I have another particle at same distance but to the left of z-axis, getting it?
Yes, sir.
So I have another particle which is at the same distance as that of first particle and it is located not to the right of z-axis
Yeah. Yes,
but
sir.
to the left, correct?
Yes, sir. Yes, sir.
Yes, sir.
This will also get me two factors. One will be along k direction, as you know, and the other in j cap, right?
So basically symmetric bodies, symmetric along the axis
Yes.
of rotation.
Yes, and the other will be in the direction j cap. Clear?
Yes, sir.
Yes, sir.
So I won't say just symmetric, Krish.
Okay.
I won't say just symmetric because a football is symmetric, correct?
Yeah. Yes, sir.
Football
Yes,
is
sir.
symmetric. But you can place a football the way that I am. Yeah.
Oh, yeah. Yes, sir.
So just symmetric won't suffice. In fact, I'll go one step further. I'll say that it is not required for body to be symmetric. What is required? That the body should be divided symmetrically by axis of rotation.
Yes, sir.
What is required
Yes, sir.
is not the body to be symmetric. If body is symmetric, more the merrier. Correct, yeah?
Yes.
As we
Does
know,
that-
more the merrier. So if body is symmetric, no harm. But body being symmetric doesn't solely address my concern. Clear?
Yes, sir.
Yes, sir.
Yes.
So what we require, what is necessary and sufficient condition? Necessary and sufficient being body should be symmetric about axis of rotation.
Yes, sir.
So even the body is not symmetric. Let me show you. This body is not symmetric, right here.
Yes, sir.
Yes, sir.
But it is symmetric about axis of rotation. Clear?
Yes, sir.
Yes,
So
sir.
this body will get me, this body will get me Lx0 and also Ly0. Clear?
Yes, sir.
This will get me both Lx and Ly0. That means for this body, I can say L vector is